Hi, I'm Aman Sehgal. I graduated from Villanova University with a bachelor's in electrical and computer engineering. After I got my degree, I worked in the industry at Lutron Electronics as an electronics and embedded systems engineer, and then I transitioned into a robotics company where I had the opportunity to work on some cool things, which really motivated my interest to get a master's degree in embedded systems. I chose University of Pennsylvania because it was one of the first programs in the country that gave a really good background in systems and platform architecture, program synthesis, and automated design verification, which were things that were pretty cutting edge in the cyber-physical systems domain. At Penn, I enrolled in some really cool classes from robotics, Internet of Things, and brain-computer interfaces. And I would like to actually talk about one of the really cool products that I developed while I was in the Internet of Things class. So this board right here is an Internet of Things platform that was designed and developed by me from the ground up. We actually ended up buying all the parts from an industrial supplier, DigiKey, and fabricating and manufacturing the board by a third-party design fab house in Brooklyn, New York.
So we would quickly go over what this board does. It's got a SPI flash chip that is used to store over-the-air firmware upgrades. The firmware is downloaded into the SPI flash chip and then upgrade the software on the Wi-Fi enabled microcontroller. It's got two buttons here, one's for resetting the target and one's for whatever user functionality is needed. This is the entire power staging area, which basically converts the voltage from the battery to a 3.3 tolerant voltage for the microcontroller. It's got two sensors. This is a aggregate of temperature and humidity, and this is an ambient light sensor. So essentially all three sensors gather local ambient weather information and cast it to the dashboard.
We had the opportunity also to bring up the board, write the software and firmware, and debug all of that and get it completely deployed and presented to people from the industry and talk about a product and what its capabilities are. So this board right here has some really cool features all the way from sensing, actuation, compute capabilities, wireless connectivity, power management, and also has an interface for users to debug and send commands to it.
So now we're probably just going to demonstrate some of the functionality of the board. I'm going to go ahead and turn the LED on and off so that you guys can see the board over here. So there you go, the LED is on and the LED is off. So now I'm going to demonstrate the firmware upgrade. Humidity is stopped changing. Timestamps will start coming in. There we go, it's back on. Firmware upgrade is done.
Amongst the other cool courses that I also took at Penn, one of them talked about the cutting edge advances in the brain-computer interfaces, a domain where we developed automated algorithms for seizure detection. We learned about how to diagnose seizure attacks, how to characterize neuronal networks in the brain. My interest in robotics led me to take a controls course. As part of this course, I did the system identification for a ball on a truss. I designed and developed the controller from scratch and implemented it in C to take in data from the sensor and provide the actuation signal to the motor. After graduation, I'll be joining a research group focusing on brain-machine interfaces, where I'll be focusing on developing real-time signal processing and machine learning algorithms for the detection of epileptic seizures. And I'm ready.